Oriented 30 degrees away from vertical.
Turn on the eraser.
Good. Oh, let me turn it the other way.
Yeah, it is.
Whoa.
That's how it is. It's not tilted towards the first one.
The light is going this way.
Right.
Yeah.
Okay? So it's got to be perpendicular to this way.
Okay.
Okay? So that's the second one. And then the third one is horizontal. So that's the third one. Everybody follow? So what's going to happen is, over here, the light is going to be unpolarized. Everyone agree? In here, what's the light going to be? Polarized, which way? Vertically. In here, what's the light going to be? Polarized, 30 degrees off the vertical, and over here, what's the light going to be? Polarized horizontal. Does everybody follow that list?
Yeah.
So we went from light that was unpolarized to vertically polarized. How do we do that? We pass through a vertical polarizer. Then we pass through a polarizer 30 degrees off vertical, and so we got light that was 30 degrees off vertical. And then finally we passed through horizontal, and so we got light that was horizontally polarized. Does everybody follow all of those? Okay? So now what we're going to have to do is just figure out the delta phi's at each step. Okay? I'm going to call these I0 at this point, I1 at that point, I2 at that point, I3 at that point. Does everybody follow this notation? Okay? The first polarizer has I0 in and I1 out. The second polarizer has I1 in, I2 out. The third polarizer has I2 in, I3 out. Does everybody follow all that? Okay. So now let's just do the math. How do I get I1 from I0?
Multiply by cosine squared of I just half. Yeah.
It's just half. What fraction of the what fraction of the incoming light goes to the first polarizer?
1/2.
So I1 over I0 equals a half. What fraction of the incoming light gets through both polarizers? That's asking for I2 over I0. So half of it gets through the first one, and how much of that half gets through the next one? Cosine squared of 30. And then I'm asked, what fraction of the incoming light comes through the first, the second, and the third polarizer? So I'm asked for I3 over I0. That's going to be half of it gets through the first, cosine squared 30 that gets through the second, because the difference from here to there is 30. What's the difference in angle from here to there? 60. So half of cosine squared 30 of cosine squared 60. Or you might even say in the other sequence, cosine squared 60 of cosine squared 30 of a half is what gets through the whole system. Does everybody follow those calculations?
So you just take the first and divide it by whatever focus you're going through.
Yeah.
Okay.
Okay, I have some questions back here. Yes? No. It's cos squared of 30 times cos squared of 60. So each one of them is a factor. You know, the first factor is 50%, and everybody knows that the cosine, you guys know the cosine of 30 squared, right? 3/4, very good. Because we square root of 3 over 2. So it's half of the original, and then 3/4 of that, and then 1/4 of that, because it's half squared. So half, and then 3/4 of that half, and then 1/4 of that much, and that's how much is getting through each stage. Okay? Question up here. Using the top one. Well, first, to get the half, I use the bottom one, right? Because when I have unpolarized light, the amount that gets out is half, period. Okay? So I just said that I1 was half of I0. And now I2 is cosine squared 30 of that. So that's why the of that is what keeps the half coming over. And then cosine squared 60 of that. So each one is of the previous amount. Okay, because I'm referencing it all back to the very beginning. Yeah. Oh, well, the I0 is unpolarized light. And when you send unpolarized light into a polarizer, you always get half. That's what the second equation means. It says I out equals 1/2 UNT is unpolarized. So I out is always half of an unpolarized source in these plane polarizers. Okay? Yeah. I can't hear the question. No, because in the intermediate step you turn the polarization until some gets out. Let's see, what does part D say? Part D says, how much light would get through if the second and third polarizers were exchanged? So here we go. We're going to exchange the second and third polarizers. Now,
none would get through.
Half of it gets to here, and then nothing.
I see what you did there.
Okay? Which way are the polarizers in your sunglasses oriented?
45 degrees. 45. 0.
This way. The reason is that it assumes that the glare that is going to be bothering you will be horizontally polarized. When you have stuff that reflects off of the surface, okay? So unpolarized light comes in like this, and it hits the surface. It leaves mostly polarized compared to the surface. So glare off of a wall usually comes at you polarized like this. Glare off of the floor usually comes to you polarized like this. If you're concerned of the glare on the hood of your car making it difficult to drive, since the hood of your car is horizontal, vertical polarizers will kill the glare. If you're in a ship tower and you're concerned about glare off the water, meaning you can't look at where you're going and you might run over some little boat, the glare off the water is going to come at you horizontally polarized, vertical polarized. And so when you make sunglasses, you know, you don't necessarily say, but I was in a situation where all the glare was coming off the wall. Why didn't you make them different for me? Well, you know, you just make them once. And so sunglasses are usually made with vertical polarizing because the glare sources that you usually need to combat are horizontally polarized. Okay? F. How are polarizing lenses used to view 3D movies? Yeah.
It's to trick your eyes into thinking you're seeing like 2 images.
Yes. Yes. So what you can do is you can take this and this, and then if you actually have two cameras in the movie theater. One of them shines a movie with vertically polarized light. The other one shines a movie with horizontally polarized light. And then, if you do this, you get one movie in this eye, one movie in that eye. Okay? Now, if you took those glasses, and for whatever reason held them like this, what would happen?
You wouldn't see anything.
You would swap the left eye for the right eye. Things that were supposed to be coming out of the screen at you would be
going
behind the screen and vice versa. Ooh. Now, I thought that was really cool. So the first time I went to Disney World, I did this. And nothing happened. Nothing happened? Yeah, nothing happened. Okay. So then I went out in the hallway after the movie, and everyone else was just walking along, and so I was hoping they would get out of the way, because I was doing this. Why was I doing this? I was looking at the glare on the floor, and I found out that at the 3D movie in Disney World, they were like this. They were still perpendicular to each other, but it wasn't horizontal and vertical, but they were each at a different 45 for those. So, I thought I was so cool. So when I went with my son to a 3D movie, I said, give me your glasses. I'll show you something really neat. So, I took my glasses, I held them up to his glasses, and I turned them to try to make one side go dark. And you know what happened? Nothing. So then I was pissed off. And then, instead of facing the glasses front to front, I found that facing the glasses back to back, it worked. Front to front, it didn't. He said, okay, Dad, so what now? And then circular polarization. Okay? There is a form of polarization called circular polarization. Okay? And circular polarization doesn't mean just up and down or just left and right. It means that the polarization is turning like a corkscrew as the light propagates. Now, there are two kinds of circularly polarized light. Clockwise and counterclockwise. And if you send circularly polarized light through a special birefringent filter, you will turn clockwise into one orientation of plane polarized and counterclockwise into the other. After that, you follow the birefringent material with a plane polarizer. So that meant plane polarizers were on the back. So when I faced the back side of my glasses to the back side of his glasses, I got this kind of behavior. But in between, these glasses turned circular to plane polarized. Now, then, in addition to guessing that, I tried to guess why. And here's my guess for why, and then I went to the web and found out that I guessed right. If you have your glasses on perfectly, and you're watching the movie, and you're trying to get tired and tilt your head, what happens? What happens if you tilt your head? If you were wearing these, like at Disney World, and you start to tilt your head, what happens? Both eyes start to see both images. So you have to hold your head just right. However, if you use circularly polarized light, turning your head isn't going to change which image is clockwise and which image is counterclockwise. And so the company called True 3D, I read their website, first thing after we got back following the movie, the company True 3D indeed uses circularly polarized light, which it then converts to plane polarized, then does this or that, so that one eye sees clockwise, one other eye sees counterclockwise, so that as you tilt your head, you don't get double images. Because my wife always complained that she got a headache in 3D movies.